All right, everyone, thank you so much for being here with us. My name is Lucio Daza. I run technical marketing here at Dremio, and today we have a very exciting presentation prepared for you, and this is called How a Self-Service Semantic Layer for Your Data Lakes Will Save You Money. Before we get started, there are a couple of things that I want to run by the audience, and first of all, let's go ahead and meet the expert today. This is going to be Brock Griffey. He is our solutions architect, one of our solutions architects here at Dremio. And Brock, I am going to run through this list of amazing items, and all I have to say is that I don't know how much I've accomplished in life because this just is great. So Brock has ran 13 Spartan races, or actually he did so the year of his wedding. This is just amazing. Also, something that I'm very envious of, he has his own, check this out, he has his own server. I call it a mini data center in his house. The only thing that I'm not envious of is the actual constant noise that those little machines can produce, even though he calls this his own noise, white noise machine. And in addition to that, Brock has a super cool Tesla vehicle, which, as we put in here in the description, he even wrote a script to pull information from it and visualize it on a dashboard. Isn't that cool? Brock, thank you so much for being here with us. How are you today?
I'm good. Thank you for having me.
Awesome. So before we get started, a couple of things that I want to mention. This webinar is going to be recorded. We will have it on our site later. It will be published in there along with the slides and the transcript. So you can go ahead and check this webinar out, plus the other webinars that we have in there in the library. So just go to dremio.com/library. You will find all our webinars, all our white papers, data sheets, you name it. All the information is going to be there. So what are we doing today? In the next 30 minutes, which at this point will be roughly 26 minutes, we are going to talk about the common challenges with semantic layers. We are going to talk about how can you reduce the complexity of your data pipeline using a semantic layer. And also, Brock is going to walk us through the best practices when implementing these kind of solutions. And time permitting, we will have a Q&A session at the end of the presentation. However, if you have any questions, please do not wait until the end. Just go ahead and put your questions in the question panel in your GoToWebinar interface, and we will try to address them as we speak. And without further ado, Brock, the time is yours. Everybody, please enjoy.
Thank you. All right, so just give you a little bit of an intro into what the semantic layer is in Dremio. Many of you may have seen this before, but really what the semantic layer in Dremio is a place that you can create your own virtual data sets, you can create your own spaces, share those spaces, and collaborate with your other data engineers or business users, and this creates an easy place for everyone to just work with the data. As you may know, there's two parts to this, right? So there's also the raw zone. The raw zone is when you register any data set from a data lake storage or another source, it will show up and become a raw or a physical data set. And from there, you can actually provision virtual data sets into your semantic area. And then obviously on top of all this, you can use your tools, right? So you can use your Python, your R, Jupyter Notebooks, Tableau, Power BI, Looker, any of those tools, any tool that can use REST, ODBC, JDBC, and soon Aeroflight, we'll be able to use all of those to access Dremio. So it's great that we have this area, this semantic area, that we can kind of go out there and create anything we want. But without a little bit of governance, a little bit of control around this, we end up getting very messy semantic layers, which make it harder for you to actually move forward. So you may start seeing things like, if you see inside here, we have this NYC taxi folder. And inside this space, we have trips multiple times. We also have matrix multiple times, and we have demos multiple times. So if you don't organize this properly and make sure that there is some kind of governance around it, you may end up in a situation like this. So this is where the best practices come in. So this is a concept that's been around for a long time. The best practices are based off of a concept of ETL and ELT and the way that you structure your data when you pull data from a source and put it into a data warehouse. Traditionally, you've loaded your data into the staging area or landing area, and then you cleanse and move it to the next base layer. Sometimes in these data warehouses, we'll call them semantic layers. And then on top of the semantic layer, you create a view layer, maybe known as a reporting layer, application layer, where you apply your business rules and definitions, and then you would expose that out to your end users. This process has been used in enterprise data warehouses for 30 plus years. As long as they've been around, this concept has been around as well. So in Dremio, the great thing is we don't have to create copies of the data, and we don't have to create all these complex ETL pipelines. We can just use virtual data sets. So the purpose of this semantic layer is to expose representation of the organization's data assets using common business terms. So it gives the business an easy way to look at the data and understand what it means. It also enables your IT to create security around everything while still promoting data exploration. So this whole thing will show you exactly how to do that. And of course, the best thing about all this is that by structuring it the way you have it, the way that the best practice lays it out, you'll learn more about where we can apply our performance accelerations, such as data reflections, to give you that even better performance in sub-second query time. So what I'm going to walk through now is the best practice, and it's going to be the prescribed layered approach to VDS creation. And just want to mention that every layer has its own purpose, and they all have their own common pattern, and it makes it easier for onboarding if you use this. So if you're going between multiple environments, so maybe you have a dev, prod, and other environments, maybe you have environment for different groups. If you're having users move between these groups, it makes it easier to onboard and get people more familiar with it. Or say you're working for a consulting agency and you're going between different customers. This actually helps too. If the customers are all implementing the same best practice, it's easy to understand the organization and layout of the environment. This also, is promoting a more performant load maintenance solution, so we can easily migrate between environments and keeps things very consistent. It allows us to have a reusable virtual data set as a building block rather than recreating everything all over the place. In the past, you may have seen tools like business objects where everyone's creating their own view of what they want to look like. If you don't govern it somehow, you may end up in that same situation. So we want to just make sure that people are following those kind of best practices. And so let me go ahead and do next. So I'm going to talk a little about the naming. So the naming of the layers is all logical. You can use whatever naming terms and standards you want to use within your own environment. But the idea is to stay consistent within the environment. So if you have different names, which I'll show you the next slide, just make sure that you follow that same naming pattern throughout your different environments. So if you have dev, prod, QA, that they're following the same naming patterns. If you're working with different customers, they may use different semantic definitions. So you just need to make sure that there's the same pattern, but the names may be different a little bit. And without further ado, I'm going to show you in practice what this looks like. So as you see, this kind of looks like our first slide that I showed you, where we have the data lake storage at the bottom. And that is your physical data sets. That's your raw zone. Then we have the staging layer. On top of that staging layer, you then have a semantic layer. And then lastly, we have a reporting layer on top of that. So each one of these will be their own space that we'll create. I'm going to walk through each space one at a time. So the sources, right? This is your physical data set. This is automatically registered whenever, or automatically created when you register a data set. And when you format them from a data lake environment, it will automatically show you a physical data set. So there's not much to this. You can't really go wrong. You'll just be able to add your data sets. In the staging layer. So this layer is a layer that we use to prevent rework. I like to think of it as a shim layer. So if we would change in the semantic layer, the source, we are able to easily just change the from clause to pick a different stage folder. And that folder should have the representation of the data in the format that it was for another source. And I'll show you a little bit later on what I mean by that. In this layer, we're going to be doing common transformations, casting for joins, but you should not be doing joins, just casting for the joins, and cleansing of data. So if you need to clean the data up a little bit. So some rules is you should have a staging folder and then a subfolder per source. In here, we're going to be doing one-to-one column mappings between the physical data set and the virtual data set, which means no joins in this layer and no grouping. Some common tasks, you're going to be looking at column aliasing, data type casting, data cleansing, and derived columns may occur in this layer. So the next layer, the semantic or business layer, this is a common view of what the business would actually look at. This is almost like your data model, right? So in this area, this is where your VDSs become reusable components for the next layer. You're going to be using folders for organization. So maybe you have subfolders called out by subject area or verticals. So it might be like customer, order, product, something like that. And that's for organization. The source data for this should only be coming from the staging layer. So we shouldn't be having source data come from within the same semantic layer. It should be coming down below from the staging layer and being pulled up. In this layer also, we shouldn't be doing any grouping, right? We want to stay away from grouping unless you are trying to get rid of duplicates. You shouldn't be doing any grouping here. Some common tasks, same thing as the one above it. You're be doing column, or one below it. You're be doing column analyzing, data cleansing, maybe derived columns. But also, this is a really great place for creating raw reflections because this would be used by many reports in the reporting layer. So raw reflections is a great place to put it as needed. Last layer is the reporting and application layer. So this is an access layer for your applications and your reporting tools and maybe for your customers, depending on how you have it laid out. And some of the rules for this layer, of course, you want to use folders for organization to make sure specific virtual data sets are located inside those folders. The source data should only be coming from the semantic layer. The source data should not be coming from somewhere within the reporting layer, and it should not be coming from the staging layer. It should all be coming from the semantic layer. This helps keep everything secured and makes sure that there is no data lineage breaks, and we also keep the performance there. Common tasks, very similar to some of the other ones. We have column analyzing, data cleansing, derived columns. Now here, we can do grouping. And I also recommend that you do aggregate reflections at this level as needed. Now with grouping, this is something you may or may not want to do because with aggregate reflections, Dremio can automatically do that, that level of grouping that you need whenever you write a query against that virtual data set. So if a tool is coming in like a Power BI tool or any other BI tool and it's doing a sum on a column, with an aggregate reflection, it will automatically be able to use the aggregate reflection while pointing to the original data set and get the performance you need. And then you can keep drilling down. So by doing that, you won't need to have the grouping happen. But there are some cases where you might want grouping to maybe remove duplicates. This is a common place that you would do that grouping. So if you do this right and you follow this approach, you'll see inside of your graph view that you will see a very straight and linear logical view of your data lineage, right? So everything should flow from the sources to the staging. Sorry, my headset cut out there. Hopefully everyone can hear me now.
We can hear you loud and clear. You're good.
Okay, thank you. Everything should flow from the sources to the staging, to the semantic, to the reporting. It should be very linear. And this helps make sure that we don't get into some problems that I'll show you here in a second. So what could go wrong? If you aren't following these practices and you start linking things together, you may start getting into some issues. And before I go too much further into that, I'm going to talk about two different things that happen here. So in Dremio, we have this concept of query planning. And what a query plan does is it plans the path of the query. It goes through and it actually gets every step that it needs to take to actually access the data and what it should be doing. So maybe it's using a reflection. It goes and evaluates, should I use a reflection or not? Should I go and access the original data? Should I be splitting this out? How many nodes do I need to use? It's the step-by-step how it processes the data. And then the other thing I want to talk about is heap, coordinated heap, right? So coordinated heap gets used when you do query planning, and if the query plans get very big or start taking up a lot of memory, they're going to, or start getting too big, they'll start taking up a lot of memory. And this is also used for internal Dremio metadata querying. So if you start having a lot of large things happen with the heap memory, you could get some problems happening. So for instance, this is a bad query plan. In this case, this user had created a virtual data set that tries to join everything together, but also does a lot of cyclical joins. So they're actually joining to the layers below it, to the layers above it, to try and create this data set. And they're also doing small joins everywhere. and building on top of each other. So they take one virtual data set and they would create a join to another virtual data set, only adding 2 columns, and they'd keep doing that for like 10 times until they finally had this virtual data set that had everything they wanted inside of it. And they may only actually use 3 or 4 of those columns, but they've created this monster virtual data set. And this will lead you to problems like this. A query plan typically lasts milliseconds to maybe 10 seconds. This one's took a lot longer because of the way this virtual data set was designed. And typically the phases are not this large. 195 is a lot of phases. Typically it's maybe 10 to 15, maybe a little more if you have a larger query. And just so you can see, when they ran that query, you can see here, this is a view of what the heap looked like. You see it go up and down a little bit, but then at the end, you see it just dramatically increase because this query plan just took a very, very long time to plan, took up a lot of memory in the heap, and just caused a lot of issues all around. So that can cause problems with constant garbage collection happening. So again, like I said, in this situation, they were doing a lot of joins to the layer above and below. They're building multiple reports off of each other, adding 1 to 2 columns at a time, and they're trying to just create this very huge data set. And this obviously is going to give you slow performance. So if you follow the prescribed approach, that will help you avoid this scenario. So how did we fix this? We just went through and we reevaluated it. We clustered similar virtual data sets together to combine them at a higher level. So we removed these small one-off joins all over the place. We also removed any circular relationships. Obviously, to do this, we had to review the profile. In Dremio, there's an option to view the profile. If you go to the Jobs tab, you can view a detailed view of what's happening. We also flattened out any of the nesting that I had going on. If all this fails, there's always the option for a temporary fix. Then that would be to do a create table as select statement. And that was done just for a temporary fix until we fixed everything else. So there are options you can use to fix your problem temporarily, but if you follow the prescribed approach, this should help prevent this from ever happening. So I remember before I mentioned the Shim layer. This just kind of gives you an idea of what the Shim layer does. So say right now today I'm using a Teradata data set for my customer view, my customer virtual data set inside the semantic layer. And the staging layer is pointing to Teradata.customer to grab these columns that have been curated to match the format that I need. That's how it is originally. But if I'm going to move from maybe Teradata, I'm moving everything to HDFS or I'm moving everything to S3, I want to be able to just change the select clause. I just want to change it to say select from HDFS customer. I can easily do that because they have the same format, because I'm not changing anything. They have the common casting already done, so they both look exactly the same. All I do in the semantic layer is say select from HDFS.customer instead of the Teradata.customer one. And now it's going to show you that that view through this the Shim layer. It creates a very easy way for us to switch out where your sources are, and your end users will never have to know. The performance will still be there, it'll still be working for them, they'll still be able to query the same data set with no problems. So I mentioned before, this helps you with your permissioning. So this is kind of a table view of what the permissions look like. So whenever you have these different layers, so you have the staging, semantic, and reporting layer, we also have the different user roles. So I'm going to look through these roles. We have like a data engineer type role, a semantic modeler role, and like a reporting developer role. And as we go down through each layer, we can see there's different permissions that would typically apply. And some of these permissions may be, these are at a high level. You can go more granular into the folders that you've added inside here. So if you want specific data engineers to only have specific access to a subfolder, you can do that as well. Same thing with any of the other roles. But typically what I do is for the staging layer, the data engineer is going to be the person creating that staging layer. So they're going to have the edit permissions. Whereas a data modeler is only going to have view permissions, and they need that view permission so they can create the semantic layer where they have edit permission. Whereas the reporting and report developer, they don't need to see the staging layer. They only need to see the semantic layer, so they have no permissions on the staging, but a view permission on the semantic layer. And then of course, because they're building the report, they have edit. And the other layers, typically I've added edit or view if I want the data engineers or the semantic modelers to be able to assist the other users, or you can have it set to none. It kind of depends on your preference there. But the idea is everyone has their own space that they have their own permissions into, so you can help make sure that no one has access to something they shouldn't have access to, but we've also made it so it's easy for us to go in and apply permissions to every level. So just to kind of give you a brief idea of what this looks like, this is just imagine Brock is the data engineer, right? So inside the source space, I'm going to have can edit permissions. This is what it looks like. If you're using the community edition, you may not see this in here because the community edition doesn't have these permission levels. But in the enterprise edition, we have the ability to specify specific users who have access to that data set. I would set myself to can edit. The other version of access is the can query version. So in the staging layer, the data modeler is going to have the can query permission, whereas I, the admin, will have the can edit permission. The next layer, I left myself with the can edit permission and semantic layer. That's my preference, but you can change that so I can only can query. Data modeler would have edit and the report user would have query. And then lastly, you could change it around. So the last layer, the reporting layer, would have a can edit for the report user, and then the data modeler would have can query. And as an admin or the data engineer, I'd have can edit. So that just kind of gives you a brief walkthrough of how that works. I think now at this point, I'm going to open up to some questions, and I'm just going to
Excellent. And I'm sorry, Brock, while you go through the questions, something that I want to mention here is there are a lot of resources that you, the audience, can go and check out if you want to learn more about what we have, about what Brock just discussed. And the first place where I want to direct you all is we have a white paper on the best practices when using semantic layers with Dremio. And here's a link. I tried to shorten that as much as I could. So please go ahead, and if you cannot capture the link, as I mentioned before, just go to dremio.com/library, and you will find there our webinars and also, of course, white papers like this one. And also, if you want to practice with Dremio, if you want to experiment, just go ahead and deploy it. Go to dremio.com/deploy. And also, if you want, and I invite everyone to, if you are not familiar with Dremio yet, go to Dremio University. It's a free online learning platform that we have developed for you to go ahead and take all the classes. You have the opportunity to launch your own virtual lab with Dremio, with the latest edition of Dremio Enterprise Edition in it. So you can kick the wheels, you can kick the tires, go ahead and try the exercises, practice everything that Brock just showed. We talk about it in, I believe, in Dremio Fundamentals, which is the first course that we have in there. You will be able to learn about data reflections as well, security, you name it. And once you're done experimenting, once you're done trying Dremio, if you still have any questions, go ahead and check out the Dremio community. Also free to get in there and start asking questions and join other folks on answering and posting challenges and whatnot. So I really want to invite you all to go ahead and check all these resources. And so, Brock, it looks like we have a ton of questions here, some that I've been able to answer while you were talking, some others that we're going to follow up after the presentation. But I see one that let's say if you want to take a shot at this one. It says, how does personally identifying information, PII, fit into the semantic layer best practices?
Yeah, it's a great question. So you'll notice that in this, throughout these layers, we have not really addressed like PII information and how that works. So typically PII information, people want to cleanse it out at the very beginning. And if you're going to do that, what you may need to do is, what we've done in the past is we've actually created a separate staging piece for your PII data. That way that data can be masked out. And typically, because of the way reflections work with PII data, I would have the PII data masked out and kept out of the virtual data sets until they're needed to be joined, or they'd have their own section throughout the layers, they have their own folder throughout their layers. This would simply pull through and allow you to join to them based on the primary key or however you have the data related to each other. and allow you to join back to get that PII information without stopping you from using your reflections.
Got
There
it.
was also another question I wanted to answer, and the question was about using virtual data sets inside of everything. So I'm just going to go back to a slide here. So referring to a virtual data set inside another data set, you should certainly always be doing that. That is how it should be done, right? So whenever you look at a reporting, if you look at this data lineage, this virtual data set is composed of multiple virtual data sets from the semantic layer. So it's taking the customer, the line item, and the orders joined together to create this report. So that's how it should flow. It should always be a virtual data set built on top of virtual data sets, but they're coming only from the layer below them. So it's a very straight lineage.
And just to clarify, did I lose? I read the question. Now I cannot see it. I think you answered it correctly. I was gonna read it for the rest of the audience, but I don't see where the question went anywhere. But anyhow, so thanks for adding that, Brock. It very helpful. So I think, are there any other questions that you would like to address, Brock? Or anything that you would like to add?
So for this specific, for the actual semantic layer, I think that is the main questions to the semantic layer. There's some other questions out there that don't relate to the semantic layer, but I'm sure we can answer them outside of this.
Yeah, definitely. We will follow up. All right, Brock, thank you so much. This has been amazing. I appreciate your time and I appreciate the sharing the knowledge with the rest of the audience. And for those of you who arrived or who may arrive late, I want to remind you this recording is going to be posted on our library later. So please keep checking our website for all the resources in terms of webinars and white papers as well. And also, if you want to see Dremio in practice or in action, we will have every Tuesday a live demonstration that you can register for. If you go to dremio.com, you will see the registration button right there in the homepage. I deliver a live demo where we tackle a couple of use cases and you can see how this whole thing works in real life. Other than that, I hope everyone enjoyed. I hope everyone has a good week. Everybody stay safe, stay healthy. And Brock, once again, thank you so much. And everyone have a good day. Bye-bye.
Thank you, everyone.